Good evening, student. Today my topic is equipotential surface. What do you mean by equipotential surface? Equi means same. So that equipotential surface means each point on the surface potential remains same or constant, known as equipotential surface. Here you write that means each point on the surface potential remains same. If you assume a point charge, so this is the point charge, that is plus q naught. That point charge which radiates electric field intensity in that direction, in that direction, in that direction, like that direction, and that is here. So if you assume a point, that point, the potential is about 10 volts. Suppose here another point is here, and that point is also, the potential is also 10 volts. Similarly, another point is here. At that case, the potential is also 10 volts. At that point, 10 volt is here. 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 Equipotential surface is an imaginary surface. So here you draw. This is the surface. In three-dimensional view, it is a spherical surface, and it also a imaginary surface. Each point on that surface potential remains constant, that is also 10 volt, 10 volt, 10 volts. Clear? Second thing is equipotential surface is an imaginary surface. Clear? Next point is it may be a surface of a body or surface of space in three-dimensional view. So each point on the surface potential remains constant. So it may be a surface of a body. If you assume that is a ball, if you assume each point on the surface, the potential remains constant. That means each point which is a certain distance from the center is r. Each point on the surface from the center having distance r. Clear? So it may be a surface of body or surface of space. Clear? Next point is surface of charged body is an equipotential surface. Means if you assume a spherical body, so this is the spherical body. Each point on that body potential remains constant. So that body whose surface behaves as an equipotential surface, that means potential remains constant. Clear? Property of equipotential surface. So first property is no work done. Produced while the test charge moves from one point to another point. That means if you assume this is the surface, here this is the point A and this is the point B. Suppose the test charge is here at point A, that moves from point A to point B. Clear? We know potential difference VA minus VB equal to what? Back done, bringing a test charge from point A to point B by an external agent divided Q naught. So VA minus VB equal to W A to B by Q naught. So potential difference is defined as work done bringing a test charge while the charge moves from A to B by an external agent. We know equipotential surface means each point on the surface potential remains constant. So potential at point A which is equal to potential at point B. So that means potential remains constant. So VA minus VB means VA equal to W A to B divided by Q naught. Okay, that means VA cancel out. Why? That is VB equal to VA because the surface behaves as an equipotential surface. So we assume VA on the behalf of VB. So 0 equal to W. So work done which is equal to 0. Therefore, no work done produced while the test charge moves from one point to another point inside the on the equipotential surface. Clear? Next point is electric field intensity. Always perpendicular to the equipotential surface. Here, suppose this is the surface and this is the test charge. This is the test charge and this is the surface. Each point on the surface potential remains constant, and that electric field which is radially outward due to point charge, that point charge behaves as a positive charge. Clear? Outward, we know the relation electric field intensity, which is equal to minus dV by dr, that implies dV equal to minus E dr E vector dot dr vector. Clear? If you represent magnitude, so dV equal to what? E vector mod dot dr vector mod. Integrating on both sides, with suitable limits, where the charge moves from A to B. Suppose the charge moves from A to B. Okay, so here point A, this is point B, integration from A to B, that is dV. Okay, electric field intensity, which is also moves from radially outward, so there is a dot product in between E and dr, so it can be represented as E dr cos theta, and the integration from is also A to B. So integration of dV means V from A to B here, and integration of E dr to be E dr cos theta. Here you write. So that means upper limit minus lower limit, that is Vb minus Va equal to what? A to B E dr cos theta. Here we know the surface behaves an equipotential surface. The potential remains constant on each point on that surface. So Vb minus Va represent as Vb equal to Va. That means if you represent Vb in the position of Va, so Vb minus Vb equal to what? Integration A to B A dr cos theta. So Vb cancel out, that is 0 equal to integration of A to B A dr cos theta. That implies cos theta equal to, that means all these things towards left side, that is 0, that means cos theta equal to 0. So cos theta equal to cos 90 degree, therefore theta equal to what? 90 degree. So the electric field intensity and equipotential surface always perpendicular to each other, because equipotential surface where electric field intensity always perpendicular to it, means electric field intensity always perpendicular to the equipotential surface, because theta is 90 degree. Clear? Or if you represent a surface, that is point A and that is point B. Okay, this is the test charge Q naught. Clear? Next point, equipotential surface indicates region of strong and weak electric fields. So equipotential surface indicate region of strong and weak electric fields. Here this is the uniform electric field where the electric field moves from positive to negative charge in both of the diagrams, and this is the plane sheet. Each point on the plane sheet, each point on that plane sheet, this point, this point, this point, this point, this point, potential remains constant, so that it behaves as an equipotential surface. Similarly, each point on that another surface, the potential remains also constant, that behaves as also equipotential surface. But those surface which is very closest to that source charge, where the potential remains more on that surface. In other way, those surface which is far away from the source charge, shows that each point on that surface, the potential remains decreases as compared to first surface. तार अर्थ है जदि गोटे आम सरफेस नवा जो सरफेस की पॉजिटिव चार्ज पाखापाखि थी तार इच पॉइंट रे पोटेंशियल कौन थी कांस्टेंट थी से पोटेंशियल को आम धरी नवा 10 वोल्ट. सेकेंड थिंग इज अनदर इक्विपोटेंशियल सरफेस नवा से पॉइंट रे तार इच पॉइंट को आम देखा पोटेंशियल रिमेन्स कांस्टेंट थी. बट से जो सरफेस टी सोर्स टाइप ठारू बहुत दूर रे थाए तेणु तार जो पोटेंशियल जनरेट हम ऑब्वियसली किसी ना किसी कम हम फास्ट सरफेस रो पोटेंशियल ठारू. तो ए पोटेंशियल को आम धरी नवा 8 वोल्ट. तार अर्थ आम कौन जानिले जदि आम इक्विपोटेंशियल सरफेस को नवा जो इक्विपोटेंशियल सरफेस टी सोर्स टाइप ठारू बहुत दूर रे थिबो ताहले भी ताईरे पोटेंशियल जनरेट हम इच पॉइंट रे आउ से पोटेंशियल सब बळे कोन रहइबो कांस्टेंट रहइबो. एवं तार जो पोटेंशियल क्रिएट हबो पूर्व इक्विपोटेंशियल सरफेस रो पोटेंशियल ठारो किछि कम थिबो. तार अर्थ हमें जानिले अलोंग द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड रे जदि हमें इक्विपोटेंशियल सरफेस को ड्रॉ करिबा तार इच पॉइंट रे पोटेंशियल कौन हम सेम रहिबो किंतु पूर्व इक्विपोटेंशियल सरफेस रो इच पॉइंट रो पोटेंशियल ठारो तार पोटेंशियल कौन हो जिवो कमी जिवो. ओके सो पोटेंशियल ऑन दैट फर्स्ट सरफेस व्हिच इज मोर एज कंपेयर टू पोटेंशियल ऑन द सेकंड सरफेस. ओके सिमिलरली सेकेंड सरफेस को जीवा सेकेंड सरफेस को अब जदि आम देखा तार इच पॉइंट रे इच जो सरफेस रो इच पॉइंट रे पोटेंशियल जदि रहिला 15 वोल्ट जो सरफेस की पॉजिटिव चार्ज रो पाखरे अछि जदि आउ गोटे सरफेस को ड्रॉ करिबा जो सरफेस की बहुत दूर अच्छी क्या ठारू पॉजिटिव चार्ज ठारू ताइरे जो पोटेंशियल मिलिबो इस पॉइंट रे से माने कांस्टेंट रहबे सत किंतु पूर्व इक्विपोटेंशियल सरफेस रो पोटेंशियल ठारू किसी ना किसी कमी जिवो. क्लियर. तार अर्थ हम कोन कले देयर इज ए ह्यूज डिस्टेंस बिटवीन टू इक्विपोटेंशियल सरफेस एज कंपेयर टू फर्स्ट फिगर. हियर हाउ टू prove equipotential surface indicate region of strong and weak electric fields. We know E equal to minus dV by dr. That means E equal to magnitude of dV by dr. In first figure, each point on the first equipotential surface potential remains constant. Each point on the second surface potential remains constant. So that means there is change in potential remains constant. Suppose that is 10 volt, that is 8 volts. So there is a difference is 2 volts. So at that case the potential remains constant. So dV equal to constant. So E directly proportional to 1 by dr. That means electric field intensity which is directly proportional to R in 1 by R. So if we increase the distance between the two plates or two equipotential surface, then electric field intensity gradually decreases. Okay, if the distance between the two equipotential surface is very closer to each other, then electric field becomes stronger from above consideration. Okay, similarly at that case, suppose this is 15 volt is here and this is 10 volt is here. So there is a difference is 5 volts each point there is a difference is 5 volts. Similarly 2 volt is here. So in both of the cases potential remains constant. So dV becomes change in potential remains constant. So E dash equal to 1 by dr, that means E dash equal to 1 by R. So that here we write the strength of electric field increases when we decrease the distance between the two surface, that is equipotential surface, or electric field decreases when we increase the distance between two plates, that is equipotential surface. Okay, so this is the reason of we measure strong and weak electric fields on the equipotential surface. Next point is two equipotential surface never intersect with each other. What do you mean? Two equipotential surface never intersect with each other. Means what? If you represent, this is the equipotential surface and this is the equipotential surface. Here each point on that surface potential remains constant. Each point on that surface equipotential, the potential remains constant. If we assume the two equipotential surface both are intersect each other, at that point of intersection there is a common point is here. At that point two potential value is there. Suppose that equipotential surface has potential on each point is 15 volts and that equipotential surface on each point on that surface is 10 volts. If two are intersect at a particular point of intersection, the 2 points value of potential which is not possible. That's why two equipotential surface never intersect with each other. If they do so, there is a common point. At that point the value of potential remains different, which is not possible. Clear? Here two equipotential surface never intersect with each other. If they do so, there is a common point. At that point there are two values of potential which cannot be possible. Clear? Next point is equipotential due to an opposite surface. Equipotential surface due to an opposite charges. Here this is the positive charge, this is the negative charge. Positive charge which spreading electric field lines radially outward, and negative charge attract that electric field lines towards. So due to positive charge, that is a point charge, so which generate an equipotential surface, that is this spherical, like that. Similarly, this one also. Why it is like that? This is very squished and this is very large. The distance between them is very large. Why? Because in that case, due to positive charge, it generates a concentric spherical region, that is a equipotential surface. Due to negative charge, that also produce a spherical region that behaves as a equipotential surface. जदि आमे गोटे टेस्ट चार्ज को ए जगह रखिबा क्यू नॉट, ए टेस्ट चार्ज ऊपर सोर्स चार्ज जो कौन पड़ो, फोर्स पड़ो, जो फोर्स द्वारा ए चार्ज टी क्वाड मूव करिवो, ए डायरेक्शन मूव करिवो, देयर इज ए फोर्स ऑफ रिपल्सन, बट दैट टेस्ट चार्ज इज आल्सो जनरेट ए इलेक्ट्रोस्टैटिक attraction due to negative charge. That means a test charge upare again गोटे फोर्स पड़ो क्या जो नेगेटिव चार्ज जो द्वारा कि एमानकर net electric field intensity becomes more, so as compared to other region. In that case, if you represent a test charge here, that test charge also repel due to source charge, so there is a force of repulsion which is exerted on the test charge, but no other charge which is present at that region. That's why that electric field intensity is less stronger as compared to electric field intensity which is generated by the test charge at that region. So due to electric fields more, so they are squeezed very closer to each other. तर फला आम देखा गोटे सोर्स जदि टेस्ट चार्ज को ए जगह रखा, ए टेस्ट चार्ज उपर जो फोर्स ऑफ रिपल्सन पड़ो गोटे चार्ज जो सोर्स पॉजिटिव चार्ज जो, अदर चार्ज तार अपोजिट दिगरे किछि नाही, तेणु आर जो नेट इलेक्ट्रिक फील्ड रहिबो आर इलेक्ट्रिक फील्ड थारू बहुत कम, कहीं आर जो इलेक्ट्रिक फील्ड जनरेट हम ए दुईटा चार्ज जो जनरेट हम, पॉजिटिव चार्ज जो नेगेटिव चार्ज जो, तेणु आर नेट इलेक्ट्रिक फील्ड व्हिच इज मोर एज कंपेयर्ड टू opposite charge which is present in outside. Similarly, at that region Q naught, same thing is happens, whose electric field intensity less as compared to that. That's why the region of equipotential surface which is very closer to one another, but other region they are far away from each other. That is the region. Clear? Now next point, equipotential surface due to unsimilar charges. Here this is the plus q charge, this is the plus q charge, so they radiate electric field lines radially outwards like that. Here due to plus q charge, the equipotential surface becomes spherical like that.